All right. Welcome, folks, to this month's AMA. As folks are joining in, I appreciate your time taking time with us here today to be talking about some repowering projects. So, as everybody's logging in, just want to remind folks we've been doing this is an AMA, this is a monthly series we do. And as we're going along, we'd love to get questions from everybody. So feel free to put your questions in. It's best for us if you put them in the Q&A section, not the chat section, and it just helps us manage those. So if you put your questions in the Q&A, we'll actually see them. They get lost in the chat more often than not. So feel free to put those in there. Love to get that info. And then we are recording this. We'll have this posted up to our YouTube channel. So for those of you back and refer to it later, we'll have that for you, and you'll get that link in your inbox as a follow-up. So again, thank you very much for joining, and we can go ahead and get ourselves started here. So we have plenty to talk about today. So again, thanks for joining. My name is Ryan Mayfield, founder of Mayfield Renewables. This AMA series is something we started over 4 years ago now, and it's been quite a pleasure for me to participate in this, be able to run this and work with so many different folks around the industry. So, at Mayfield Renewables, we are consulting engineering company. We do a lot of project engineering, working with EPCs and developers first and foremost. We do a lot of work around energy storage systems. So solar plus storage systems are really our specialty. And then do a lot of education as well. And so my passion really lies in doing education. And this is just one of those things that we do. So these monthly series, the intention here is to, get you all, the audience, the industry, some information on timely topics and be able to engage with some really smart folks within the industry in order to, make sure that we're getting that information out there and working with everybody. So thank you for that. And so I do want to introduce our expert guests today. And so we have two great folks joining us to talk about the repowering. And so I'll introduce them, but then I'll give them each a moment to kind of, just introduce themselves, kind of where they're at in the industry. So Joe DiStefano, I think I got that, the Director, Special Projects at Cleanleaf Energy. So special projects, we've been working with Cleanleaf. So I know Joe, and we've worked with Cleanleaf, formerly Borrego. And so I think I know a little bit about special projects because we've talked about this in the past. But Joe, tell us a little bit about, what you're doing and kind of what special projects means to Cleanleaf.
Absolutely, Ryan. And you got my name just about right. It's DiStefano for clarification.
Stefano.
But
Oh man. See, I
Joe
even asked.
DiStefano.
I'm sorry. I got flustered.
No worries, no worries. So Joe DiStefano, I'm the Director of Special Projects for Cleanleaf Energy, formerly Borrego. Cleanleaf is a national O&M provider in the DG utility scale sector. My team specializes kind of outside of O&M services and O&M contracts, and we're focusing on remediation, repowers, commissioning, due diligence, site visits, a lot of out of scope type of scopes of work that no one's really entertained at the time. But right now, a heavy focus is on repowers and remediation, and also doing a lot of decommissioning as well.
Great. Yeah, thanks for joining. And as we're going along, we're gonna, obviously this is a conversation. The three of us will be talking, and again, with questions coming in. But towards the end, we have some projects that Mayfield and Cleanleaf have worked on together. So kind of highlight those in order to kind of drive home a lot of the things that we're saying. So, but first up, Jose Colom, Applications Engineering Manager for Home and C&I at SMA. And so, yeah, thanks for joining us, Jose. We've been talking for quite a while as well. So yeah, I guess interested to hear, your role at SMA and then kind of as it relates to the topic at hand. Oh, I think you're breaking up on me, Jose. Oh, and we lost Jose. So we'll come back. We'll let Jose introduce himself. But in the meantime, as he's rejoining us here, we'll get going and talk about this. So Today's topic, talking about the PV glow up, repowering challenges, opportunities around PV systems specifically. So, this is a topic that has come up quite a bit for us, specifically as an engineering firm, and for both Joe and Jose. Jose, I see you're back. Are you with us?
Yes, can you guys hear
Okay.
me?
Yeah, yeah, no problem.
Yeah,
Perfect.
sorry. I
No,
had
no, no.
a little inconvenience on my end.
No worries. I just jumped into it, so actually, let's go backwards a little bit and let's go ahead and let you introduce yourself and kind of where you're at in the industry and stuff.
Oh, well, thank you.
Yep.
So my name is Jose Colom. I'm the applications engineer manager for, I would say, string inverters here in SMA America. I've been with the company roughly around 9 years, and I will say 14 in the industry, right? We cover anything that it's home, CNI, and the large scale segment. Specifically for my role, pertaining to the large scale segment, we're going to talk about the PEAK3 product.
Perfect.
Thank you.
Yeah, absolutely. So with that, we'll jump into the topic again, talking about challenges and opportunities around doing these repowering systems. So as we jump into it, kind of setting the stage, as we like to do on the webinars here, defining a repower. And this was something as we were doing prep for this, both with both Jose and Joe, and even internally within Mayfield, these different naming conventions come up. And so, definitely want to recognize, and I think Joe, even in your introduction, you talked about I think you threw out some of these. And so curious to hear, just talk with you guys about this. Generally, we're, look at repower versus maybe a revamp of the system. If you're only touching a few of the components, maybe if you're doing a one for one type of a change, a swap out for the inverter, things like that, versus doing a complete, tear off of the roof and adding new modules, which we've seen as well, or inverters. So I guess I'll open this one up for you guys as well. So just kind of some of the language that you guys are using, and again, try not to get too hung up on all the different ways of saying it, but are there different ways that you look at it and kind of classify it differently within your organizations?
So I would say, we hear different ways of doing the same thing at the end, which is repower or repowering. Uh, we get I want to retrofit, I want to repower, I want to bring my system back, and make sure that it's working. So for us, we don't necessarily go into the wording itself, more of what we're going to be doing. From an inverter manufacturer perspective, we look into, how easy could it be to replace the inverter, right? Take the inverter that it's not working out of the equation, put a new one. By a new one, it could be either one or multiple inverters, depending on the existing inverter that it's on site.
And Ryan, on the Cleanleaf side, I mean, we probably bucket these, we'll call like a retrofit would be kind of, we're replacing a couple inverters, maybe a SMA, a Chanda, whatever we're replacing it with, like for like, with the same electrical characteristics. We'd probably characterize that as like a retrofit.
Mm-hmm.
We use remediation a lot, more on kind of like our rack and wire management repairs. And if we're going in and replacing a few inverters, we'd probably, definition for that would be like a remediation project. We throw repower around a lot loosely in all different situations, right? I know we spoke on the last call, and we were trying to like define like what we thought a repower definition should look like. We pretty much call anything that if we show up to site and there's an inverter offline and it needs to be replaced, we're calling it a repower, whether it's repowering with the same characteristics or if it's any sort of capacity upgrade, we're going with a repower for that.
Yeah, and that's great. And that's, a lot of, so we received a lot of questions ahead of time. So I really appreciate it from folks. And so I was, kind of looking through those. And one of the, I think, big questions common question that came through is around utilities and what that restructure, if you need to, restructure any agreements or net metering agreements and things like that. And so one of the things that we when we're working with our clients, our contractors, one of the big things is as long as you're not changing that you're not increasing that AC capacity, that's been, for us, that's been the line in the sand. So if you come in and you have a 500 kilowatt AC output inverter and you're replacing it with 500 kilowatt inverters, or, you know, aggregated capacity of 500 kilowatts, you're not changing your net metering agreement. And so the utility, you're not going to be affecting their line, because very often 10, 12, 15 years later, you know, the original agreement that you put in place, the other systems have come online on their feeders. And so they want to make sure that you're not going to be putting on more power than what they originally were expecting. And so I think that's been a big part of what we've seen, and kind of the approach that we're taking on those. If you do want to change that, if you do want to increase it, and we're going to talk about some of the things that you can do, or maybe some of the driving factors around it, that would be, and one of the common questions, do you have to get a new net metering agreement? If you're changing the capacity, absolutely. What we've seen, as long as you're not changing that, then you're fine with that on that repower side. All right, so let's talk a little bit about some of the value add opportunities, maybe some of the reasons why you would go about and do this. You know, I would love to hear from Joe and Jose on this, just because you guys are seeing it from a little bit different perspective. From what we're seeing when we get these opportunities, when we get requests around this, it's very much around the inverter. More often than not, it's the inverter that's failed. The site owner needs or wants to get that system up and going again. And so there's these other opportunities. I would say that all of these things on the screen are there as opportunities, but very often the driving force is, I'll put it mostly at the feet of the inverter manufacturer. I know inverter manufacturers, for the entirety of the solar industry, it feels like they get the blame, or they get whatever for everything. I realize that, so somewhat picking on you there, Jose. But you know, the inverter is probably one of the things that is most likely to fail, although we have seen rework because of warranty issues on a module, so a complete array getting pulled off a roof because of warranty issues around a module. So not to say, so that does happen as well. But I guess I'm curious on your guys' end, you know, what you are seeing kind of driving most of these repower opportunities, and then we can kind of talk about some of these other opportunities that come along with it.
Jose, you want me to go first?
Go for it.
So I would say majority of the time, you hit the nail on the head there with the module warranty claims. A lot of times you get into a situation where owner was successful with a module warranty replacement. You're pulling all the glass off the building. You have to install all new modules. It's a lot of work to, like, you know, take everything off and put it back on. It's a perfect time and opportunity to start thinking about some of the repowering opportunities. You know, whether it's due to aging equipment, sometimes, you know, you got these projects going where you got a bunch of string inverters, maybe 40% of them are offline, and they just waiting for them all to go offline before they go out of business, or whatever the case may be. But a lot of times it's usually around the warranties. Either a manufacturer goes insolvent and there's no warranty and no parts is a driving factor. We have situations where we have building hosts want to do some roof upgrades and some warranty work to their roof, or whatever it may be. So typically there's a cost sharing involved to take a project off the roof. So a lot of times we'll approach a customer and say, listen, like, this is a perfect time. I mean, if you got cost sharing, it's a perfect time to start doing some upgrades. But a lot of the driving factors for us are failing equipment, and, you know, turn the IRO, the rate of return into a recovery on the return, right? But mostly it's around manufacturers going insolvent.
Totally agree with you, Joe. I think at this point, the majority of the times that we get a request for, it's when an inverter manufacturer is out of business, or they want to bring up, refresh their warranty, like we are pointing out in here, right? The old inverter does not have any warranty, right? They need to replace or troubleshoot something that is going on with that inverter, and it's easier for that. It's easier or better for that at that point to replace with a newer inverter. We see that often, right? And I would say that's how the approach we typically take over. Yeah.
Yeah. So glad to hear that we're all kind of seeing the same thing. And so some of the, opportunities, I think one of the biggest opportunities, especially now, kind of where we're sitting in the industry, is that integration of energy storage. So, Joe, you mentioned, doing re-roofing, things like that. I think that's a perfect time to be having those discussions. Does the building need maintenance? Do we need to be doing other things while we're going through this exercise? We're going to talk about a specific case. It happened to be a carport, so that would be a moot point in that situation. But it may be that there's only parts of the system that are down, only a few of the inverters or some of the inverters are down. And so this is an opportunity to kind of look at the system as a whole and give it new life, if you will, and making sure that we're going to get another 10, 15, 20 years out of it. But energy storage being something that we're seeing more and more of, but integrating storage this is a perfect time to be able to do it. If you are trying to bring down some of the other costs, so some of the grid support features, doing demand charge reduction, things like that. If that's something that the client is interested in at the same time, then this was, a perfect opportunity of being able to integrate that, get the right inverters, the new inverters in place, and put that all into play. And then a lot of these, what we're showing here, these opportunities, these are ancillary, I would say. They're going to come right along with changing or doing a repower of sorts, changing out the inverter or the modules themselves. So, you're going to be seeing a data granularity, being able to do that. Your total energy harvest you should increase that system capacity. Again, that gets back into what your original agreements are with your utility. And so looking at California specifically, having moved to NEM 3, changing your net metering agreement is probably not going to be something you want to do, just as a general blanket statement. But of course, these are opportunities that you're going to look at and trying to understand going into it. So yeah, and then there's the O&M aspect of it as well. If you are able to get better data collection, newer inverters, those kinds of things, then that's definitely part of the O&M process, something. And so I'm sure, Joe, that's something you guys are looking at as being an O&M provider, something that you're trying to incorporate into these systems, I suspect.
That's correct, Brian.
Yep.
Anytime we can bring value to the project, increase the warranty, and a lot of times, a lot of these rooftop systems, they have an extension for the PPA agreement. I don't think a lot of owners are looking at that long term until it really gets to the point where the system is so degraded that you don't have a choice but to repower.
Right.
Mhm.
Great. And I do see that we got a live question here. And so it's about the net metering agreement. And so each one of these, kind of want to really should be going and looking at what that net metering agreement is, what the original agreement was. As again, I'll just kind of make a blanket statement, and because it can apply differently across the board. But what we've seen is, as long as you are not increasing, I should say, as long as you're not increasing the system capacity, the AC output capacity, that's where being able to stay under the original net metering agreement's been fine. Of course, you probably want to go and look at those agreements to make sure that you're not missing something, that there's not some sort of a clause or something in there about making any sort of changes and having to notify the utility of that. But our experience has been, as long as you're not increasing it, then it's been okay to do.
Brian, and it's good
Yeah.
to point out that it's not only with California here specifically. I know the question is referring to them, but it's also with any jurisdiction out there or any utility out there, right? You want to make sure that you're keeping that nameplate. At least of us from an inverter manufacturing perspective, we try to keep that same nameplate capacity and not exceed those ratings, just to avoid new interconnections agreement or any changes in the current contractual agreement.
Yep, absolutely. Perfect. Okay. So gonna try and touch on saw some of the questions that are around this, and so I'm gonna see if I can incorporate some of the questions that we're getting live, and then also some that we got previously around this kind of concept, these evolution of PV systems. So, one of the, I would say, number one things that I know that we're looking at, it's one of the first things that we jump on and we focus on are system voltages. And so, if you haven't been in the PV industry, for many, many years, it's it's interesting to look at kind of how the industry has evolved in terms of just around voltages themselves. And so back in the day when we first started seeing a lot of net metering systems, they were really all 600-volt systems. And we'll get into inverter topologies next, but 600-volt DC systems were really what we were doing. We would see whatever our utility interconnections were. So we were doing at 208 volts, 480, doing single phase systems at 240, obviously. But these system voltages, it's a pretty important thing. And I see that somebody was asking about restringing of arrays. And so the system voltage itself is important, but also a very, very large part of this is going to focus on, say you're you're replacing an inverter, you're keeping the PV modules. What is the voltage of those modules? So if you get back and you get into some early 2000s era modules, they're likely only 600-volt modules themselves. And so you can't restring them, even if you would be able to bring in a new inverter or something like that to a 1,000-volt system or a 1,500-volt system even. The module listing is an important part of it. And then right there with it is the wiring system. So, being able to look at that, all of the system components, what are the ratings? What are we limited to? And Joe, I was going to ask you a specific question around this. So I see a question about the restringing. The Are you at Cleanleaf, are you investigating that as an option? If the modules themselves are 1,000-volt rated, is that even something that you guys would be looking at, or are you trying to utilize and touch it as little as possible?
It all depends on the scenario. Typically in a rooftop application, we trigger new NEC requirements for rapid shutdown. So we already assume we're gonna have to do some restringing, especially
Okay.
for the old 600-volt legacy projects. On some of the newer 1,000-volt rated systems, we'd love to, save the combiner boxes and the DC string wiring infrastructure and just focus on the equipment. It all depends on the condition of the wiring as well, right? A lot of
Sure.
these cables are sitting in the sun, whether on a roof or in a field, baking in the sun. So a lot of times we'll just restring the project out of just best practices.
Okay. Yeah, and there's been some changes. So codes and standards is up there as well, as probably most people know, one of my favorite topics, but we've kind of gone back and forth a little bit on the wiring systems that are acceptable, the free air wiring specifically. So we're actually seeing in code today, you mentioned, bringing things up to current code, Joe. The current code very often says that we can use, well, it does say we can use USC-2 conductors for our free air conductors, which is what we were using way back when we were doing grounded, when we were using isolated inverters. And so that's definitely something that's, comes up, being able to reuse that equipment. But you also need to, is it in good working condition before you start reusing it? So inverter topologies, that's another big one. And there were some questions I saw around that. So I kind of want to bring Jose to give you an opportunity to talk about this. So again, for the folks that maybe aren't history buffs or haven't been in the industry for a super long time, prior to our transformerless inverters, we were using transformer-based inverters almost exclusively. So we had inverters that utilized a transformer, and so we had the DC and the AC sides isolated across this transformer. And so back then we were calling the systems grounded. We were grounding the DC side. We would actually take typically the negative, but in some cases the positive, but typically the negative side, and bond it to ground. We would have a grounding electrode. 2014 code was all sorts of fun in terms of how you could actually do this or what the requirements were. And the industry has moved away from those. And so, Jose, I'd like to give you an opportunity to talk about inverter topologies, kind of what you're seeing today, and big considerations when you're talking to folks about replacing these inverters. What are some of the major considerations? And I think grounding is one of the big questions that comes up a lot.
Yeah, totally. Thank you, Ryan. So we see this question quite often, and I see that in the Q&A, we got a question which you already asked Joe about replacing SATCON units. We see that often, right? Um, Mostly at the time, those were negative grounded systems, or how we're referring to nowadays, right? What we do typically, our at least our inverters requires a floating array, right? So the way we work around this is we typically try to avoid restringing or having to tell the customer that they need to restring for their sites. So we potentially look into if the solar company or the panels that are installed for that site would allow for any configuration of that array to become a floating array, right? If that's even possible, if it is something that was allowed after the site was implemented, then it could be an easy installation of our inverter at this point. And that's how we look at the systems, right? We try to take the easiest approach for the installer or the company who's working with the systems, where we try to make it again, take out the inverter, put a new inverter in, and yes, there's a difference in topology. It used to be a grounded inverter, now a grounded array, now it's a floating array. But we try to work with that without any restringing, at least for the customers.
Yeah, and I think it's probably worth noting, we're still going to everything's still going to be bonded together. We're not losing that. So kind of making sure that we are using our language right. And so our systems are still going to have a reference to ground. We're still going, and especially ground mount systems. I mean, you put all that metal into contact with the earth, and you put all those modules in direct, electrically they're bonded together. And so we have the systems they're connected to the earth. They are grounded. We're gonna maintain that EGC, the equipment grounding conductor, or the bonding, running that to the inverters themselves. So we're eliminating these transformers, which is what was requiring those dedicated DC grounding systems, really, is what it comes down to. And so I have yet to see a system where it's where you can do it. I think the one, and I would love to hear from both of you guys, because maybe you've run across those old SunPower positively grounded systems. Have you guys run across those and had a successful way of doing a repower around those?
So with those, we work with third-party companies where we provide a galvanic isolation in between, just to
Okay.
keep that same topology. Yeah.
Okay.
That's
Yeah, and
what we're doing.
I've seen some of those products out there offering some galvanic isolation, and so there's DC to DC converters out there that are something that you could consider. I saw that in one of our other questions as well. There's products out there where you can do that, maintain that galvanic isolation, and then potentially even changing your voltages to match the new equipment while leaving the original equipment the same, because you're keeping the input side of it the same. You're not changing that equipment on that input side, and then everything on the output is what would get changed there. So, yeah,
Totally.
great.
Well, another thing that I did want to point out is that we sometimes see this 600 volts, and when customers look at it, it's even, and when we have the conversation about the replacing these inverters, it's also like Joe pointed out, it might be worth it to as well replace the array, right? Bring up that system to a newer module out there. So instead of using a 600 volt, maybe you have the opportunity to bring it up to 1500 volts. Therefore, it could be a better potential for those inverters that you're going to be replacing with, not only with ours, but also out there.
Excellent. Just saw a good question come in from David Robinson, and so glad you could join us, David. It's around these new inverters, and I like to talk about the ground fault protection. But David asked a great question about the arc fault detection. So curious from the two of you, kind of your experiences, what you've seen, just kind of set the stage a little bit. So when we're putting in new inverters compared to older inverters, we had our isolation transformers. We had ground fault protection in those old systems. Very often we didn't have any arc fault protection, but we would have ground fault protection. But the way the ground fault protection would work is across a fuse, And on small systems, I forget what the cutoff was, maybe 30 kilowatts. Somebody can correct me if I'm wrong, but there was a power cutoff where that ground fault protection fuse would be 1 amp for small systems and actually up to 5 amps on larger systems. And so our ground fault protection now is much more sensitive, and it's will catch potential ground faults that maybe you didn't catch before. I'm curious for you guys, the arc fault protection. What are you seeing in terms of that and these new inverters on these old systems? Is it creating any sort of problems?
Not at all. From our end, it's not. When we look into this system, this is something that we consider not only arc fault but also ground faults, right? Nowadays, newer inverters offer both capabilities. So our inverters do before starting operation, they look for ground faults, and if the measurement is within the limits, then the inverter starts operation, and then during operation it keeps on measuring as well. Same thing with the arc fault, right? If there's any arc fault detention from the DC side, the inverter would cease operation and then point out that there's a fault and restart, and same thing. So yeah, but no, it's not an issue that we have seen. Again, it's not the first system that is out there. We have quite a few systems going on, and no.
And that's the same on our side as well, Ryan. Haven't really seen any sort of nuisance tripping or ground fault detection to date. Not saying it doesn't exist, but I haven't had any
Okay,
experience.
you're not seeing. I was curious. We've been part of the engineering side, but not the commissioning side. So I should talk to some more folks who are doing that, and interested to see if the ground faults, if you're finding ground faults that weren't there before or didn't show up before, may have been there before, but just with our increased sensitivity, I would imagine that there's probably some that are showing up that didn't show up before.
Yeah, I mean, I will say, like, on some of the older, like when we're adding string inverters and like optimizers to older modules, we do have some nuisance tripping due to modules having some leakage to ground or back to laminate and stuff like that. But it's usually because of equipment failure that's driving those nuisance trips.
Gotcha. Interesting. All right, let's move forward a little bit and kind of talk about the planning around this. And so I think some of this might get to some more of the questions just through the discussion. But just talking about effective planning around this. So, from our perspective, I would just say that these repowering jobs are never quite as easy as I think most people walking into them think they're going to be. Quite honestly, they're more complicated than I think we originally thought back, a few years ago when they first started seeing these come up. But yeah, I'd like to kind of just talk about, the planning, kind of the documents, the things that you're looking for, and, kind of what it is, what you're asking for. And Joe, I'll start with you. You kind of, what's the input that you're looking for so that you can come into this a little bit more knowledgeable and being more effective?
Yeah, so off the jump, we go through the as-built and we do a quick site survey, check the conduit schedules, look at the infrastructure, because pretty quickly we can figure out how invasive the project's going to be, right? If you have a lot of small conduits, a lot of conduits not oversized in the project, it gets a lot more expensive when you have to start bringing in excavation and conduits and stuff like that. But I mean, step one's the as-built. Financial agreements, we typically don't get those. We ask for them a lot. We kind of want to know where the customer stands in the project, what's left on the investment. Something we'd love to have. Would probably help us tremendously speed up the process to telling a customer if the project's viable or not. I mean, pretty much nailed it right there with these four. Main thing for us is the as-built, and then equipment selection, if any. A lot of times customers come to us, they don't have any equipment selected. They kind of say, hey, we just want to get the capacity back as close as possible. So we're pretty much relying on the as-built drawings.
I agree on this one. The main one that we ask for is as-built drawings, right? We need to look at it. So especially the team that we have in-house, it's looking at the as-built drawings. We look into the details. Going back to the previous slide where we were talking about inverter topology and the voltage, the system voltages, we look into those details, right? We need to know what we're working with. I would say we typically start on the DC side. We work our way all the way to the AC side of the system in order for us to determine what's the ideal inverter. We got a few different options, and depending on the system configuration or the as-built is where we're going to look for. That's how we determine which is the best SMA inverter to use for each of the applications out there. Another thing that we look into is the interconnection agreements. We might not specifically ask for the interconnection agreements, but we do ask, like, for example, when was the system installed initially, just because it might have been prior to rapid shutdown if it is a rooftop system, or right after, or if the customer needs to bring up to code the system when he's doing the repowering. Again, this all depends on the different AHAs out there and the specification, if we call it grandfather back to the day where the system was installed or not, right? Those are kind of the things that we look into when working repowering with string inverters.
Yeah.
Ben,
Oh, go, Joe.
Oh, Ryan, that's what I missed. Like, something we do ask for a lot, or typically ask the client to look through their agreements, is the host agreement with the building owner if it's a rooftop project. A lot of times there's some stuff baked in there, whether it's cost sharing, whether it's you need to remove my system 1-2 times in the life of the system. A lot of times, if you look at that and you talk to the host, I can guarantee you that somebody wants to do upgrades to their roof. Somebody has some HVAC project in the back of their mind. They're waiting for this solar to get off the roof to install it. So a lot of times there's an opportunity there to work with the owner and the host and come up with an agreement to make the project, economically viable. But that's all I have on that one.
No, that's great. It was like during our prep conversations that, I think you were the one who brought up the financial agreements, and then exactly that, just kind of what's the agreements with the host? We don't have it on the list here, but that's definitely a big one of, if it's on somebody's roof, is there still a PPA intact? Did it get through all that? All those things are an important part of it in order to understand, kind of what the expectation will be for the client and the host. And so for us as an engineering firm, we're looking at those as-built and kind of jumping right into, what's the engineering solution? How can we make this work? How can we put this puzzle together? But there's a lot of stuff that's in there in the background. So really encourage people to think about those, especially on the financial end of it, because that can make a big difference on the whole thing. Engineering considerations. So I think, the three of us are, involved in this as well. So, I think once you've got yourself set up, kind of some of these questions that you're asking. And so we've touched on this a little bit, but maybe we can expand on it. But, what can we reuse? What kind of inverter replacement are we having? Capacity limitations, we've touched on that a fair amount. Grounding versus ungrounded. Are there other questions? Jose, I'll start with you on this one. Are there other questions as the inverter manufacturer that you're jumping into when you're getting into this part of the process for the engineering considerations?
Well, I'll be honest. I think the four that we're pointing out in here are kind of how we attack the system, right? I'll start with, is it a like for like when replacing the inverter? Is it a central for string inverter? Right? We look at those options. It could be a central being replaced with multiple string inverters, right? Let's be honest, our first central inverter back in the days, it was on 125 kW inverter. This inverter that we have here in the image, which is the SHP or Sunny High Power, it could be a 125 kW as well. So yeah, and going back to your question, this is more or less what we look into, what can be reused from the balance of a system. So like I was saying, we try to keep it as minimum of replacement as needed. So for example, try to keep the same AC BOS, try to keep the same DC BOS in place, right? And just take out one inverter, maybe put 1-2 more, add a panel board with some breakers, and that could be a central for string replacement. So I would say this nails out pretty good.
I agree with you, Jose. I mean, the biggest thing for us is the balance of system components and what's reusable and what's not reusable.
Mhm.
We're really focused. We're really like laser focused on the conduits because that's kind of what makes or breaks some of the projects is what's already in the ground if it's underground. And then some of the larger components, transformers, panel boards, and stuff of that nature.
It's
And then
good
the
that you
whole,
point that out. Sorry,
yeah, there's a
Joe.
whole, sorry, and there's a whole other, then if you're repowering if you're doing a module repower, then it's a whole different rabbit hole, right? Because nothing's compatible, nothing fits, everything's a big process. And then you start changing the configuration of the landscape to portrait or vice versa, and then racking manufacturers get mad at you, but there's no other solution, right? If I buy a microwave anywhere in this country, I can plug it in anywhere in this country. Solar modules don't work that way, unfortunately.
Mhm.
Right. Yeah. Just all the way down to the quick connects that we've have. The evolution of those in of itself can be a issue. And so, a couple things I want to touch on. One is a question that we have, and so especially around repowering rooftop systems, question came up. Do we need to put in rapid shutdown? And Joe, you mentioned when you guys are looking at those, that's kind of an automatic thing. If you're doing a rooftop system and you're doing a repower, you're looking at bringing it up to the current code, which includes rapid shutdown. And then a question that came in from Kelly before the webinar was asking about using 3741 systems instead of rapid shutdown. And 3741 is a big topic. We've talked about it a lot here at Mayfield on previous AMAs and done lots of research and content on it. But I guess I would say it's potentially a possibility. The problem I see, and I guess I would open this up to you, Joe and Jose, if you have opinions on this. The issue that I would see it is that the racking system, the 3741 listing is attached really to the racking system. And if you are leaving the racking system in place and you're really just replacing inverters, and you're taking the approach of trying to put the inverters up at the rooftop to meet that 3741, you kind of met it, but unless that racking system hasn't changed at all since it was installed, and that racking system now carries a 3741 listing, you might have something there, but I still think that the likelihood of that being the case is going to be very, very low. And just the fact of the way that the system was installed probably wasn't installed to what the addendums are for those 3741 systems. So yes, a possibility. No, probably not very likely, I guess is kind of where I would go with that
Totally.
one.
Yeah, I would say I totally agree with you on this one, Ryan. I was, if anything, it would be for us where EO 3741 might come into play if it's a system that was installed under NEC 2014, where you can place the inverter nearby the array. And if you have that conversation with the inspector or AHA and you're able to say, hey, I'm just installing the inverter nearby the array. Can we make it play as in qualifying for those rapid shutdown requirements back when it was NEC 2014?
Yeah.
But yeah, I totally agree. Nowadays, with it's mostly tied to the racking, and my assumption is that the rackings that were used back in the days are not certified at this point.
Yeah,
Right.
really, really tough to convince an ASJ otherwise. I mean, they're gonna go right for the rapid shutdown. Every electrical inspection in this country now is laser focused on rooftop solar. So it's all up to the ASJ.
Yeah, so curious on that one, Joe. When are you guys involving the AHJ into the conversations? I think that's been a pretty big theme of the questions we're getting both live and previous to this. So kind of curious on your approach on that.
We try to approach them pre-construction. We typically get the same response out of like 95% of them. Submit your drawings and we'll make a decision. So they typically want to wait for a stamped plan set, and they won't even take an IFR set. They want to see a stamp on it. So typically we haven't really got much feedback pre-construction. I will say certain states like Massachusetts, New Jersey, we already know the answer because we've already done it a bunch of times. But yeah, it's pretty much up to them, right? In the end, they're going
Sure.
to issue the permit.
Yeah, and this is I feel like I say this a lot in these situations, but asking for forgiveness is generally not the best approach. Just it's going to be an expensive approach if they don't grant that. So, making sure that you are doing that. And I mean, when it comes right down to it, I know that there's jurisdictions where, you put in a PV system and they're, making you bring other parts of the electrical system or other parts up to current code. So
Yeah.
not even changing anything, just adding this completely unrelated system. So I think that there are a lot of AHJs that are going to want to see this, brought up to the current code and make sure that it's being as safe as possible. So I think that should probably be the approach that most people take. All right. The other point that I wanted to make, I knew this slide was coming up, so this kind of gets back into the engineering side of it as well, but I'll let Jose kind of talk us through what we're looking at specific to the SMA inverter. Thing I like to point out is, we have manufacturers that are seeing this as a issue that we need to solve within the industry. So we have equipment that's being designed and built for it. But one of the things I just want to point out is this this power curve or this power graph that we're looking at here. All inverter manufacturers are going to have something similar to this. And so when you're going and replacing inverters, again, if you're trying to do that one for one, you're putting 1,000 volts 50 kilowatt inverter and you're putting it in place of a 600 volt inverter, you really need to pay attention to what those operating voltage windows are and what the power output is. And so I think that's what kind of relates here to this. And so Jose, I'll kind of let you talk about the PEAK3 FLEX and kind of what it is that's, how SMA is trying to approach this problem of repowering systems.
Yes, thank you, Ryan. So sure. So the approach we take with the Flex or the Sunny High Power PEAK3 FLEX, by the way, by Flex we mean as in a power class, which is fully adjustable. This inverter is capable of installing anywhere from 200 volts AC to 660 volts AC. It is UL certified to all voltages. And with that, for example, you can see here in the slide where it says 52 kVA for the 200 volts reference, and then 172 for the 660. Another example will be a 480. This will be a 125 kW inverter. At 400, it will be roughly a 100 kilowatts or kVA inverter. The relationship we're seeing here, it's roughly anywhere to a 1.4 to a 1.5 multiplier from the AC to the DC. Sorry, the reason why I bring this values are because the 1.55 will refer to what is the minimum voltage input for operation, or as in starting voltage for operation of the inverter. And then the 1.40 will be the minimum voltage in the MPPT window for that AC voltage reference. So for example, if we take the 480, you multiply that by 1.55, that gives you the starting voltage of the inverter. The 1.4 will be the lower end of the MPP voltage range.
Oh, got it.
I do want to tie in this with a few questions that I saw on the Q&A. For example, there's one where talking about replacing the transformers and when it's a good moment to add or adding a step up or a step down transformer. And I would say that this is something that we look into every system out there. For example, there's systems out there that are 690 volts AC, where we are close to that range, but we are not there. We're on the DC side, the array is either a 600 volts or 1,000 volts. So there were 690 volts AC systems with 1,000 volts AC. What we are telling customer at this point is sometimes, hey, it might be good either to add a transformer in between the 690 all the way down to, for example, a 400 volts AC. Therefore, we can play within a good range for that DC voltage array, 1,000 volts array that you have on site. So it gives us a few flexibility, pointing out anywhere from 600 to 1,500 voltage DC. And yeah, this is the solution that we specifically use for repowering. So it's the PEAK3 FLEX.
Yeah, and like I said, I'm really glad to see inverter manufacturers recognizing the issue here and bringing products to market. Another question that came in was talking about and see if I could kind of encapsulate this, but using a inverter, again, 1,000 volt inverter on a 600 volt system. We've done that on plenty of systems. What you get is naturally the power output of that inverter is going to be reduced. So yes, you can use these higher power inverters or this higher voltage inverters with an existing lower voltage input, but you're going to have it at a reduced power output. And I have seen where, just going in and being able to limit the power output of the inverter as well, going in and programming it is an acceptable solution to the utility so that you're not putting in more power into the utility. So you replace a 50 kilowatt inverter with a 60 kilowatt inverter, but you make that 60 kilowatt only produce 50. So you're able to meet that requirement.
It's good that you point that out, because this inverter allows you to set in a specific nameplate. We provide a marker that it's UL approved, that allows you to, for example, if you need to meet a nameplate of 60 kW, to type in or fill in 60 kW, and that will be your nameplate value. So yeah,
it is. That's become what it is. It's now a 60 kilowatt inverter. Nice.
bingo.
Excellent. Well, I see that we're getting close on time, and I do want to also make sure that we look at least this case study, and then we had some other slides that I'll probably have to breeze through here. But this was a carport system that we worked on with Cleanleaf, and kind of, Joe, if you want to just kind of talk some of the highlights on some of the decision making, what the system was and kind of where it went, and and just kind of how it went for you guys.
Yeah, 100%. So high level, this was actually a 1 megawatt project with two 500 kW central SatCon inverters. We had one of them fail. We had a catastrophic failure. It was unsalvageable at the point. We were working with the client for about a year trying to come up with a design. We reached out to Ryan and his team. Ryan got us a good set of drawings, got us a good design for half the system repower. This was a pretty interesting project. This fall under the DSA in California. We had to resubmit a whole set of drawings, go through the whole approval process for about a year. Kicked off the project about a year later. Great thing about this project was this is in a parking lot of a school, right? They did not want us to saw cut the parking lot. Ryan's team did a great job doing their due diligence, going through the conduit schedules, checking all of our existing conductors, vetting out all our new conductors, getting all the pipe fill and all that stuff vetted out. But yeah, it was a pretty interesting project. We removed the 500 kW and we installed a bunch of solar edges at each carport with optimizers. The reason we selected the solar edge product was we had a 200 volt AC output. That was due because they had some weird car chargers on site, so we were kind of limited for the voltage. So at the time, this was before SMA came out with their new line of inverters, there was no solution. I believe, Ryan, this was a 208 inverter we installed.
Mm-hmm.
And we would, we're within where it was 10-12% plus or minus. But
Yeah. So that was it. I think we were a little bit lucky, I guess. Those old SatCon inverters were putting out 200 volts AC, and so that became a big sticking point. How are we going to do this? The client was insistent on keeping the one SatCon that was still working, I think, against both Cleanleaf's and Mayfield's against our recommendations is the word I was trying to go there. But yeah, and being able to reuse a lot of the equipment, but that it took a lot of time and effort to go through what are the conduits, what are the conductors in those conduits, and how can we make the system utilize as much as possible.
Yep. Then outside the electrical, and state of California, all the seismic mountain and all that, those inspections. So, I mean, all in all, it was a lengthy project from pre-construction to permitting to build. But I would say I think we're up to like 13 repowers, Cleanleaf in the last 3 years. It's probably the one we're most proud of because we caused zero impact to the school, right? We didn't saw cut their parking lot. We didn't have to go back to the client and say, hey, we thought that was a 2-inch conduit. It's actually 1.25 inches. We actually went out and did the survey pretty thoroughly. But yeah, it was definitely a successful project. We energized, I want to say 9 months ago. And look, I haven't got a call back. I talk to the client once a week on other projects, and he's super psyched about the outcome. But yeah, it was a good project for sure.
That's great. And looking forward to when the second SATCON goes out, and maybe cutting a little bit of the time out of the process and understanding how we need to get to from A to B a little bit quicker. There's actually a good question that came up asking about spare parts market for defunct inverter manufacturers. I don't know of anything. I know that, AES still does some service. I should say that last time I checked, they were still doing some service, but it was not an easy process by any means. And so I certainly would not rely on that. I believe there's people out there that kind of specialize in the SATCOM stuff, but Joe, you may know, if that's even economically a viable way of going about things.
I mean, there's definitely a market out there. I don't have any like great contacts around like who to call, but I will say, I mean, we deal with a lot of portfolio customers, right? So sometimes in these situations that when we're removing an inverter, we'll strip all the parts out of it for them and box them up, try to label them so they have their own spare parts for existing portfolios. But yeah, I mean,
Yeah.
I tell you, I throw away a lot of old SATCONs, a lot of AEs, a lot of old equipment, and we try to take some of the, the important like IGBTs are tough to get, right, for the SATCONs, so we'll take those out, and stuff like that. But no, off the top of my head, I don't think there's like a great one-stop shop for
Right.
used inverter parts. I know there's a company, Blue Wave, who's has some parts here and there, but I don't know
Okay.
how
Good
extensive
to
their
know.
line is.
Good to know.
Yeah.
Okay. We're coming right up on the end of. So we were going to talk through the single line. So this was the existing single line, just kind of showing, here's what we have, all these DC coming into the combiner box. And ultimately, kind of where we went was, again, utilizing some of the existing conduits, things like that, being able to reuse a lot of that equipment. And so a lot of due diligence, a lot of time. So I think kind of the big takeaway in 30 seconds here is probably give yourself a lot more time than you expect, and make sure that you are getting out there on site, understanding what's exactly out there, and taking your time and doing all of that research to make sure that you have a more successful project in the end. So yeah, so some of these key takeaways. We talked about a lot of these things, which type of repower, looking at those different definitions, the equipment, what you need to replace, what you can reuse. That's always a big part of it. And then, trying to find other ways of taking this opportunity to repower your system. Is it adding storage? Grid services, that might be something the utility's interested in now that we have our smart inverters and things like that. So definitely our inverters having that functionality is an important thing. And then, yeah, just looking at the different components that are available. I do want to flash this up on the screen, just make sure folks know how they can get a hold of us. And then also just take a moment. Joe, Jose, I really appreciate you taking the time. All of the attendees, I appreciate you taking the time. Yeah, here's our information, questions and comments. We'd love to, hear from you. I know that we weren't able to get to all of the questions, but yeah, definitely appreciate everybody's time that you spent with us here today. And then two last things I have for you are, we at Mayfield, we love talking about codes and standards. We have a number of online courses that we've been developing, in-person classes as well. So happy to talk with you about, doing some of those things if it's of interest to learning more about codes and standards or other topics. And then next month, we are going to be talking about advanced control on microgrids. So interesting topic that we have coming through on that. So look forward to seeing folks there. So again, Joe, Jose, I appreciate your time. Thank you very much for your insights. I know we could spend a lot of time talking about this, obviously, breezing through it at the end there. So thanks so much.
Thanks all.
Thank you, Ryan. Thank you for having us.
Awesome. Okay, thanks. We'll see you all later.
See you.
Bye-bye.